Hello everyone. In today's video, we're going to be covering the IXL assignment on adding and subtracting numbers that are written in scientific notation. One of the key parts on scientific notation is we have to work with decimals. Therefore, I want to do a very quick reminder on how to add and subtract decimals before we hop on over to IXL and do the full-fledged problems. On the left here, you will see a nice little reminder on how to add decimals. The nice thing is, with adding and subtracting decimals, it's not all that different from standard column addition and subtraction. The key for both of these is you need to ensure that you line up your decimals. So when you're adding or subtracting, you do need to line them up, which does cause the need for you to fill in any empty spaces with a 0. And once you're done adding, you just bring that decimal point straight down and you're good to go. And the same thing is true with subtraction. The only difference is, remember, when you are subtracting, the larger number, so the larger value, needs to be on top. And if we look closely at these examples, notice that we were adding 10 and 5/10 and 11 and 74 hundredths. Since you're adding, it doesn't matter which number goes first. But what does matter is the decimal points needed to be lined up, so a 0 needed to be added as a placeholder. And then just add straight down, bring your decimal down, and you're good to go. Over here in the subtraction example, thankfully it is written as it should be, but when you do subtract, that larger number, if you're not working with integers, needs to be first. And just like with addition, line those decimals up, which does cause you to add a 0, which incites that borrowing. So we're going to do some of these examples together. Just wanted to give you this nice fresh little reminder to say, hey, it maybe has been a minute, but adding and subtracting decimals isn't super different than standard addition and subtraction. All right, with that being said, let's hop on over to IXL. And I'm going to go ahead and place this anchor chart here. As you will see, this anchor chart is a little bit larger. There is also the ability to remind yourself on how to multiply and divide with decimals. That's not the focus of this video, but it could help you with future assignments. So you do have the full picture here. All right, let's focus it on IXL. We are doing the assignment add and subtract numbers written in scientific notation. And our directions in this case tell us to subtract and write your answer in scientific notation. One key point is that in order for us to either add or subtract, the scientific notation portion, so the exponent portion, needs to be the same. That kind of brings us to combining like terms, because if they are not in the same format, if they don't have the exact same exponent, then they're not alike. And therefore, you would have to do an extra step and change them to ensure that they are in the same format. This one's already set up beautifully for us because both of our values are being multiplied by 10 to the 9th. So when they are the same, all you got to do is subtract the decimals and leave your 10 to the 9th power the same. That's pretty easy, right? We're going to subtract our decimal values. And then when we're done, we'll just put a times 10 to the 9th at the end, and it'll be set. All right, when we subtract, make sure you line up those decimal points. 9 and 75 hundredths minus 2 and 69 hundredths. these line up beautifully. I don't need to add any zeros as a placeholder. But when I do go to subtract, I will need to borrow, because in this instance, I cannot do 5 minus 9 because we're not working with integers, we're not working with negative numbers. So we'll borrow from that 7, which makes it a 6, and my 5 becomes a 15. 15 minus 9 would be 6. 6 minus 6 is 0. Bring that decimal point straight down. 9 minus 2 is 7. And our original problem was times 10 to the 9th. And my answer here is still in proper scientific notation, because my answer, my value, still falls between 1 and 10. So no changes need to be made, which means I'm done. Not too bad, right? But of course, we'll do a few more examples. And here we go. All right, we have another subtraction one. We'll go ahead and do that because in my opinion, adding is always easier because you don't have the borrowing. First thing to look for is make sure that the exponent is identical in each term. I see that they are both being multiplied by 10 to the 4th. Which means I am set to just subtract my decimals. 8 2/10 minus 4, and I have to line those decimals up, and 602 thousandths. In this case, because I had to line the decimals up, I have some empty spaces. So what does that mean I need to fill in with? Yeah, I need to fill in any empty spots with zeros. All right, let's do some borrowing and subtract. I can't do 0 minus 2, can't borrow from that 0, so I got to come way over here. And I borrow from the 2, which makes it a 1. And this 0 becomes a 10. But I got to borrow from him because I really need a number in the ones place. 10 becomes a 9, and this 0 is a 10. 10 minus 2 is 8. 9 minus 0, 9. Uh-oh, can't do 1 minus 6. We'll borrow from the 8, and that becomes a 7. So our 1 is now an 11. 11 minus 6, 5. Bring down that decimal point, and last but not least, 7 minus 4 is 3. And we got to make sure it's in scientific notation. Bring down our times 10 to the 4th. Nothing changes there. And my answer is in proper scientific notation still, because this value right here, written with black ink, falls between my parameters of greater than or equal to 1 and less than 10. So we're good to go. My biggest thing is make sure that you guys are careful, because obviously with borrowing, it can get a little bit messy. So just be as neat as possible when you are subtracting and working these out by hand. All right, when we add, it's the same thing, only you add. So let's see if we can find a slightly tougher problem. Ooh, this is a good one because we have, all right, let's try this one. First things first, remember we have to make sure what is the same? Our exponent. And it looks like they are. They're both times 10 to the 3rd, so I'm good to go. Which means we just need to add our values in front because this one is an addition problem. 4 7/10 plus 3. Now I don't see a decimal point with my 3. hopefully you guys recall that every number technically has a decimal point at the end. But if there's nothing to the right of the decimal point, there's no need to write it. It would be a waste of time. And mathematicians, they like to take as many shortcuts as possible. And so therefore, if they don't have to write the decimal point, they ain't gonna do it. But in this case, we're gonna need to add it in because our decimal points need lined up, and we have to add a 0 in as a placeholder. But 3 and 3 0/10 are equivalent, same value. All right, we'll add straight down. 7 plus 0 is 7. 4 plus 3 is 7. 7 7/10. Put it in scientific notation, times 10 to the third. Last thing I always do is I make sure that it still is in proper scientific notation. It is, because 7 7/10 falls between my parameters. So we're set. And here we go. Ah, this is a good one. And this could be our last problem. We'll see. I know on a prior video, I kept saying it was the last problem. I kept adding more, but this one might end up being our final type and our final problem here. Because when I look at these, notice that the exponents are not the same. What that means is I need to change one of them, it doesn't matter which one, so that way the exponents are identical. To help us remember how to do that, I'm going to bring up a prior anchor chart, a prior set of notes on how we can change from scientific to standard notation. I won't necessarily be completely leaving scientific notation, but we do need to move our decimal point, because by moving the decimal point, that is what affects our exponent. So we have two options here, guys. Either on this first number, we can move the decimal point, so that way we lose a spot and it becomes 10 to the third, or we can go to our second value here and we can add a decimal point movement, so that way it becomes 10 to the fourth. Doesn't really matter which. I'm going to go ahead and look at my answer choices to help me decide which way I should move it. I see 2 answer choices are to the fourth and 2 are to the eighth. So because I want to work smarter, not harder, let's change 5 times 10 to the third so it's written with 10 to the fourth. All right, we have 5 times 10 to the third. Very first thing I want to do is I want to add in that decimal point so I can visualize where it's at. It's right here at the end. And if I want to add a decimal point, which direction do you think we need to move it? We're going to move it to the left, because it's kind of like how we go from standard to scientific form. Because when I went from standard to scientific, I would move to the left to get it into proper form. And if I'm going from a 3 to a 4, how much do I need to move it? 1 space. If we move that decimal point right here, I'm adding 1 movement, which means I'm adding a movement. I'm adding 1 to my exponent. This becomes 0 and 5/10 times 10 to the fourth. Now, do we have matching exponents? We certainly do. So now we can do what I hope is the easy part and add our two values. So 7 3/10 plus 0 5/10. Line up those decimals. 5 plus 3 is 8. Ooh, that's a slappy 8. Bring down your decimal point. 7 plus 0 is 7. And it's times 10 to the 4th. Standard form, we're good to go. All right, we're actually going to do one more of those because I do get that that's a little bit trickier, so I want you guys to be able to see a second example. So this one will now, in fact, be our final example for the video. When I looky here, are my exponents the same? Nope, one is 10 to the 6th and one is 10 to the 7th, so they're not identical. Like last time, that means we need to change one of them so it will no longer be in the proper standard form, but I gotta change it so that way I can subtract. Even though it doesn't matter which one you change, I wanna work smarter, not harder. I'm gonna look at the answer choices to help me see what is the wiser decision. And it looks like all of the answer choices are to the 7th power. So once again, I am going to change the second value. So we have 9 63 times 10 to the 6th. Okay. With this, we're going to kind of focus in our directions from standard to scientific. If I were to undo it, that means I had moved my decimal point 6 places. That's what that exponent means. I need to move it one additional place because 6 plus 1 is 7. And if we look at our directions here, in order to have that positive exponent and to add 1, I moved to the left. So our decimal point is going to move one place to the left, which means our exponent for scientific notation purposes needs to increase by 1 as well. Our equivalent form of writing this is 0 963 thousandths times 10 to the 7th. Now do our exponents match? Yes, they certainly do. So we're ready to subtract. 2 83 hundredths minus 0 963 thousandths. I've lined up those decimal points, which means I'm going to need to add in a 0 as a placeholder. Can't do 0 minus 3. We need to borrow. That becomes a 2. This becomes a 10. 10 minus 3 is 7. Can't do 2 minus 6. Gotta borrow again. 12 minus 6 is 6. Oh, some more borrowing. Can't do 7 minus 9. 17 minus 9. 8. Bring down our decimal point. 1 minus 0 is 1. And then we are multiplied by 10 to the 7th. So there we go. Beautiful. All right, everyone, I hope that was beneficial and helped clear up some of your questions. But as always, if you have more, send an email to your teacher or join us for help sessions. Good luck.